Okay.
This mom will know what you're doing in school.
One more section.
Proving them wrong is what you're doing. Brad.
All right. This is the last section before we have a quiz, which your quiz test, whatever you want to call it, will be on Monday. Over 4-1 to 4-3, and I'll give you a review sheet tomorrow, so you'll know what to expect. All right, so we're going to talk about angles a little bit. This slide really, nothing really to write. Just make sure you understand how an angle is formed. So you have an initial side, and you measure the angle, and then you have a terminal side. What's terminal mean? Yeah, it ends, right? So that's the side where it ends. You measure the angle in between. And then are we comfortable with 1, 2, 3, 4? Okay. And let's see. I think while we're at it, because you have some room here, can you draw another set of quadrants here? And we're not going to need this for a couple slides, but I'm just going to tell you now. It seems you don't know this mnemonic from last year. It seems like it was new to you. All students take calculus. Does that sound familiar at all? Yeah. Mr. O? Okay. So A, S, T, C. So, of course, the first letter stands for the words I just said. So all students take calculus. And you're like, where is this going? Some of you that don't know. The A stands for all, and it stands for all the trig functions. So all the trig functions, sine, cosine, tangent, and the reciprocals, they're all positive in quadrant 1. What do you think the S stands for?
Subtraction.
Not sum, but
Subtraction.
super. Sine.
Aw.
Sine is positive in quadrant 2, which means the others are negative. Now, sine has a buddy, doesn't he? Or he? Yeah, cosine. So if you think about it, if you have the number 2 and you flip it, doesn't it stay positive? So not only do you have sine positive, you also have its reciprocal cosine.
What is that a plus sign and a T below the A?
Plus, all these are going to be plus.
Then what does the A stand for if S stands for sine?
All of them are positive. All 6. How about the T? What do you think that stands for?
Well, I'm not going with this. What does the A stand for? Like going downwards. Like we have some going downwards.
It's not one of these cross things.
Here, if this make all are positive. The word all, and like it's all.
Just making sure.
Okay. Tangent is positive here, so therefore what's the reciprocal of tangent? The cotangent is also positive. And then how about the C?
Cosine.
And the reciprocal of cosine. C. Okay.
Are we allowed to call sine, cosine, and tangent sin, cos, and tan?
I prefer not. Okay. So we'll use that in a little bit. Okay. When we measure an angle, you may remember we measure this direction, right? Is that clockwise or counterclockwise? And if I go fully around, how many degrees is that? Okay. So a positive angle is measured this way. A negative angle is measured the other way, which is clockwise. Good so far? So when use the word rotation, a full rotation is the 360. So if I want to know how many degrees are in a 2.25 rotation, you're just going to take 2.25 and multiply.
I have a question. Is it really necessary for you to delineate the difference between clockwise and counterclockwise high schoolers?
Yes, I think we should.
That's bad.
Okay. Let's be nice.
Okay, I will.
All right. Take 2.25 times 360 for me, please. You getting it? Okay, 810. All right, go ahead and do number 2.
That's fine.
All right, what did you get? 540. Oops, see? I'm doing more stuff. All right, now, the whole clockwise business means your angle is going to be negative. So you're taking 3 times negative 360 this time. Or if you don't like that, you can just multiply by 360 and then just make sure you put negative on. I don't care. What do you get? Negative 1080. All right. So that's easy, right?
Uh-huh.
Okay. So next, vocab word. So you told me, what did a terminal mean again? End. And what's co mean? Together. Or, yeah, ending together, or ending with, right? So, coterminal angles are angles that end together. Right? Now, they may have different measurements, but they end in the same place, right? So, can you think up to today, because we talked a little bit on Monday, angles that end at the same spot, but they're technically different? 180 and 180 and negative 180. 0 and 360. That's probably the most common one, right? Negative 360, 360. Get where we're going? Okay. So, and also, if you think about, if you use the word terminal side, say that you measured this angle, if you go around one more time, you can say they share the terminal side. Okay? So angles that share a terminal side. And you gave me lots of good examples. 0 and 360. 360 and negative 360. How about, can you give me one that's coterminal with 90 that's negative? Yeah. So what do we do to bounce from one to the other? Like, how do we get to a coterminal angle? Perfect. Okay. So 2 parts to the question then. It says identify all angles that are coterminal. So if we have 217, all the coterminals would look like 217 plus any multiple of 360. And you might be bothered that I only put a plus. But if k is an integer, the negatives are taken care of, right? So you're also subtracting. So k is an integer. And then to find one of each, to find one positive and one negative, take 217 and add 360, and then take 217 and subtract. Okay. Okay, go ahead and do number 2. TJ, can you give me the two angles you got?
I got 315 and -405.
All right, sounds good. All good so far? All right, and then in radians, what's one full rev? So since this third one's in radians, we're gonna add and subtract 2 pi. So all of them would look like pi 6 plus any multiple of 2 pi. So pi 6 plus 2 pi k. And then we're going to add 2 pi, which will require a common denominator. So 6. So now we have 1 pi plus 12 pi, so we have 13 pi over 6. And then if we have pi over 6 minus 2 pi, so that's 1 pi minus 12 pi, so negative 11 pi over 6. So 2 pi in radians is 6 degrees, going all the way around the circle.
Oh, okay.
So it's just doing yes, and if it's radians, it's 2 pi. Okay. Alrighty, now we'll get into the really good stuff. Okay, have a circle there. And
She's down here. You don't have this.
what's the radius of that circle?
It's 4.
The radius.
I tell you.
I think I'm ill.
No,
R. Yeah?
Oh. So I have to try to get through this.
It was like kind of a trick question. So radius is R, right?
Yes.
And so take a circle, you can always draw a right triangle in there, right? Using a point on the circle. Okay. Okay. So this is some coordinate x, this is y, and then that distance would be called r, yes? And we know from Pythagorean theorem that x squared plus y squared is r squared. Therefore, r, if you solve for r, you get that. Okay. So what we're going to just do SOHCAHTOA on that right triangle using theta as our reference. So looking at that right triangle, what is the sign of theta?
Y over there.
Good. So cosecant? Good. How about cosine? And secant? Tangent?
Y over
Uh-huh.
there.
All right, awesome. Okay. So if you are given a point on the terminal side of an angle, so that just means like if you were to graph that point, it'd be here somewhere. So you're finding that angle you're using that angle as your reference. Now the picture isn't as important in this one as just using those definitions we just wrote down. So here's x and here's y. And then we're gonna solve for r. So we know r is the square root of -4 squared plus -6 squared. Okay, before simplifying the radical, what do you get under there? 52? which breaks down a little bit. What goes into 52? 226. Yeah, so 2 rad 13. Okay, so we're just going to go through all 6 up there, starting with sine. So sine is y over r. So negative 6 over 2 rad 13. No. What's that? I know. 2 things we're going to simplify, right?
Yeah.
The 6 and the 2, let's get rid of those first because that makes a 3. And then Bailey knows she's excited. She wants to rationalize. Okay. So multiply by rad 13, so negative 3 rad 13 over 13. Now I have 3 versions of the answer now, right? 1, 2, and 3. Which one should I flip for cosecant?
Second.
Second. Yes. Second.
Which one can we flip and have no work to do?
Second.
Second one. This one, if you flip, you'd still have to cancel out the 2 and the 6, so you might as well go here. So cosecant is going to be negative rad 13 over 3. Any questions so far? All right, let's go to cosine then. Cosine is x over r. So similar here, negative 4 over the 2 rad 13. Again, the 4 and the 2 can cancel. And rationalizing it, negative 2 rad 13 over 13. All right, which version am I flipping? Yep. Oops. Tan, that's the best one. No, no radicals.
Not very radical.
So negative 6 over negative 4, y over x, and then all you have to do is simplify the fraction, so 3 halves. And then cotan is 2/3. All good?
Almost. What happened? Oh, okay, what side's the terminal side? I don't understand a single word of this.
We're just using these involved. You don't even need a picture, you just plug them in, x, y.
Oh, okay. The terminal side's the side that's like on the radius.
Yeah.
I picked the wrong day to put smoking. I don't care.
Alright. So here's where the little ASTC thing comes in. So state the sign, the actual sign as an SI at the end, so plus or minus, in that particular quadrant. Now, I'm curious if you remember, where's 3 pi halves? In, like in degrees.
It's like 75.
No, 75.
No.
270.
It is at 270, right? Once you do more of these, you'll take that up a little more. But it's at 270, right? And
What's
what's
stint?
2 pi?
Oh, it's fine.
So this is saying from 270,
All the while I was just looking at this thinking, what's stint, cost, and
it's
tan?
just the variable is t instead of x. So 270 to 360, can you picture it? What quadrant? Okay. 270 to 360 is in quadrant 4. So
Bless you.
if we look at this, what's positive in quadrant 4? And therefore the other two are negative. And it's only asking about those 3. So we know that cosine is positive, cosine of t is positive, sine of t is negative, and tangent of t is negative. So if you need to remind yourself what you did here, ASTC. Pretty easy, right? Since you have a trick. All right, what quadrant is 192 located in? Yeah, the T, the third. Because 180 is here, 270 is here, therefore it's here. It's positive. Yay.
We love positivity.
Yeah, we do. All right, and this part's kind of setting us up for the rest of the notes. Yeah, go ahead.
Is that what
It is. Okay, so when I ask you about pi thirds, let's kind of recap from Monday. Do you remember how many degrees pi thirds is? 60. So one way to do this is to say I have two 60-degree angles, right? 2 pi thirds, so I have 120. Another way, do you remember, so pi is here, right? Okay. So if you make a semicircle and you cut pi into thirds, yes? Think pizza, you would go here and here, right? And if you wanted to complete the circle and cut it in thirds, you'd have this, yes? So I need 2 slices of pi thirds, right? So here's your first slice, here's your second slice. And now you can see you're in quadrant 2, 120 degrees. Okay? What's that?
It's like the first thing seems to want me to.
Yeah. I'm just showing you both ways. So let's draw it. So we're here. And this is 120. So the full line is 180, right? So my next question for you is, what's this angle right here? All right. Conveniently, that's one of our reference triangles, isn't it?
Yes.
So, and like tomorrow on your little quiz, you'll only be in quadrant 1 tomorrow. Now, but here, what goes across from 60? Rad 3. What's the other leg? Yeah, and so it's 1, but since we're in this quadrant, because x coordinates are negative in quadrant 2, it's going to be negative. And then how about the hypotenuse?
2.
Okay. So the question is, choose the point. There. The question is, what is that blue point right there? You guys are fast. Yeah. The x coordinate is -1. The y coordinate is rad 3. So the point is -1, rad 3. You like it? So the rest of the lesson, this slide, and then the extra sheet, because I forgot to put something in the notes. We're gonna finish up with that. Okay, this picture looks almost identical to that other one I gave you, doesn't it? What did I do? No?
You told us already.
I told you R. What's R?
R is 1.
R is 1. And you may remember, whoops, a circle with a radius 1 is called a unit circle. Okay? So let's go through and redo those ratios with this picture now. So sine would have been y over 1, right? What's y over 1? Just y. So therefore, if we take the reciprocal of that cosecant is cosine. You get
Okay.
You're right. Tangent and cotangent didn't change.
It's 2. Let's just see.
Wait, move us. Taking a nap on Cindy's back. Almost. Okay. Now, before we do these, what is that blue point? I heard it. What's the radius again? So the radius is 1. This point is 1, 0. Okay? Paul, stay with us, please. You're gonna miss stuff. And how many degrees or radians are right there? 0 or 2 pi or degree wise? 60. Okay. Okay, you may want to drop those down too. Okay, how about here? What's this point?
0.
1. And how many degrees?
90.
How many radians? 5 halves, yeah. So 90 degrees, pi over 2. The point is 0, 1. How about this leftmost dot?
-1 is 0.
Good. And degrees and 8 radians there?
180 degrees. And
Wow, you guys are good. All right, and the fourth point.
0, -1. 270.
5 over 2. Awesome. Okay. So, notice the next 3 examples all land on one of those 4 points. They're all like an axis angle. I'm gonna call them that. So let's find 3 pi halves. So 3 pi halves is here. So what I like to do is I like to find the angle, write down the point, and then decide
Yes.
which rule to use up there, right? So sine is y. What's the y coordinate here? -1. Negative pi, that's coterminal with which one on my graph? 180, because negative pi would be measured this way and land right there. cosine is the x coordinate, so -1. You're excited, aren't you? You really are excited. So 90 is here. Okay. So tangent is y over x. So you get 1 over 0, which is 1. Right. Now, what if it was 0 over 1? That is okay, and that would equal 0. Awesome. Okay. All right, this is kind of like a puzzle, right? Find cosine and cotangent if you're given this information about sine and the fact that tangent is less than 0. So let's draw our little ASTC thing and figure out what quadrant we're in. So what two quadrants is tangent negative in? Tangent is negative. A is all, T is tan. Okay. But we can't have our answer in two quadrants, so this also helps us, right? Sine is positive. Which two quadrants is sine positive in? Therefore, both things have to be satisfied. Where are they both? Yes. Okay. So we know we're in quadrant 2. Okay, so draw a little picture. We know that sine is a fourth, so that means the opposite leg is 1, and the hypotenuse is 4, and quadrant 2. How can we find that other leg? Okay, go ahead and do Pythagorean theorem to get the missing thing. That's fine. Okay, and there's one little thing we need to, yeah, because we're in quadrant 2, the x coordinate in quadrant 2 is negative, so you would have to note that it would be negative. And then you're just going to find both of these. So cosine is going to be negative rad 15 over 4. And then cotangent is going to be the adjacent leg over the opposite leg, so negative rad 15. Now notice one thing, and we're going to talk more about this on that extra sheet. You're always using the angle that's right here. Okay?
So your finger is always the one that's of the adjacent side. Like if the angle that's. That's what I was gonna ask.
And I think I'll have you draw something on your extra practice that might help. Okay. So like I said, I needed to really add one more slide in the notes, so I just made this extra handout. Grab that. We're just going to do the front side today, and then we'll do the back tomorrow as practice. No, I don't do unit circle, I just do the reference triangles.
Okay.
And I'm gonna show you how I do it. Yeah, in just a second. Okay. So this has a selection of all the types of problems we'll see. So what we're gonna do, so from yesterday, hopefully you can fill those triangles in no problem, right? Maybe you already have. So go ahead and fill in the triangle sides. We'll do your practice for tomorrow. I know, they're all fun. I know. It's so weird. Abby, Kate, and Aiden are all
Yeah.
fun.
And Paul would if I wasn't here, he'd be asleep too. I'm wiring pieces of mine.
I know you are.
I know you are.
Okay. Also, go ahead and fill in those 4 points. Basically, if you can do the 2 triangles in those 4 points, you can do all 4 trig problems. I'm gonna give you one other little kind of help. Okay? Did you notice that on the notes, the ones we just did, like I said, they were all landing on one of the axes? But do all angles land on the axes?
No.
So we're gonna have some in between, right? So the scenarios you're gonna get in between are gonna be one of these 4 triangles. And I call this a bow tie. Because I get some weird pictures sometimes when people draw like a triangle like that. So if I give you this little tip, it tends to help. So when you're drawing a triangle, it should be one of those 4, okay? And you're always using, we were just talking to Bailey about it, you're always using the angle closest to the origin as your reference point. Okay? And then I'm gonna add one more thing, pluses and minuses. The x coordinate here is what kind of number?
Positive.
The y coordinate here?
Positive.
And then r, the hypotenuse, is always positive. So like in this scenario, it's plus, plus, plus. How about in quadrant 2? What's the x coordinate?
Negative.
Y coordinate?
Positive.
And the hypotenuse is always plus. That shares leg here. What about the y coordinate here?
Negative.
Shares a leg there, and then the y coordinate here,
Negative.
and the hypotenuse.
Positive.
So you'll have one of those, and we'll fill in the appropriate things here in a minute. Let me do these. Okay, so number 1, sine of pi. Sine, or pi is right here at -1, 0. And now that you don't have your notes in front of you as much, do you remember what sine is? Sine is y, so sine of pi is 0. What quadrant is 120 in? Yeah. Okay, and we actually drew this earlier. So let's draw 120. So that's 120. This is where the bow tie comes in. you're not extending it here, right? It's gotta be part of the bow tie. So your triangle comes down to the x-axis. So you're that quarter of the bow tie. And then just some arithmetic tells us that this would be 60 degrees then. Because if this is 180, Abby, 180 minus 120, what would be left over would be 60. So you can always like do the subtraction to get to it. And then you fill in your triangles, sides. So across from 60
Yes.
is rad 3. This leg would be -1, and the hypotenuse is 2. And then it's cosine, so adjacent and over hypotenuse. So adjacent leg is -1, hypotenuse is 2. So -1 over 2. All right, why don't you try number 3?
Yes, I heard.
What's the fraction look like?
Oh, it'd be only fine. It's negative.
So you should get, you're here, you have 0, -1. Tangent's y over x, so -1 over 0, which is undefined. Questions so far? Dave?
It's a reasonable question. How do you know when you use that bow tie thing guide versus like that little guide you just did?
Bow tie is when you're in between, when you actually have a triangle form. Notice 1 and 3, we just landed on the axes.
Oh, you said yes.
Yeah, so the axes, you're just using the 4 points, otherwise you're using the bow tie. And like I say, I do it a little differently than the unit circle. I like the reference triangles because not a huge fan of memorizing lots of stuff. So I like to be able to tell you can always construct it. Okay, 3 more. Okay, so again, what was whoops. What's pi thirds again? It's 60. So one way, Kendall's favorite way, right? You can do 4 times 60, which gives you how many degrees? 240. What quadrant is 240 in? Third. So one option, you can just go straight from degrees to the drawing. It's going to be here, but then the question is, how do you know what angle it is? Like, how do you know what angle goes here?
We could convert that into degrees, oh, wait.
So we did. So the fastest way is that if you're doing multiples of 60, that has to be 60.
Oh, that's.
Or if you think of this as 180, how many add to 180 to get to 240?
That's how I was thinking of it, but your way's better.
Now there's another way too, and this could help some of the more visual learners, so I'm going to show this to you too, okay? So you remember the whole, there's pi, right? If I'm doing pi thirds, I need 3 slices of pizza, right? On the top and bottom. So you would have 3 up here, and my picture is kind of not to scale, but you'd have 3 down here, right? And I want 4 of them. So starting here, you would count 4. 1, 2, 3, 4. And then you know you're in quadrant 3 with a 60-degree slice because backwards.
What you did, like you said, chemical early, that was just essentially multiplying by one.
No, that was just taking pi thirds is 60 and doing 4 times that.
Okay.
My only concern is that that part of the quiz will be no calculator. And if I gave you like a bigger number, but it shouldn't be that big. Okay, so then we would just fill it in. So 60, across from 60, we'd have negative rad 3, negative 1, and 2. And then we would do cotan. So cotangent is going to be adjacent over adjacent over opposite. So we would have negative 1 over negative rad 3, which is 1 over rad 3, which rationalizes to rad 3 over 3. All right, try 5. This one. Okay, make sure you went the right direction. So negative. So here's negative 2 pi, right? And then negative 3 pi would be here.
So what's that?
That last slide on the notes, right, has all the wherever your notes is. No time.
On the notes. Right here, right here. Right here. Oh,
So secant is going to be 1 over x,
okay.
and the x coordinate is negative 1 in this case. So you'd have 1 over negative 1, which is negative 1. How many had negative 1? Questions? All right, last one. What's pi fourths in degrees? 45. So first way you can do it is I need 7 copies of 45. So what's 7 times 45? Negative 315. So doing that, you would start here, and you would have to end up in quadrant 1, going in the negative direction. This would be here. And this would be 45. The other way you can do it with pizza, take pi. Now this time I want slices, 4 slices, right? Because it's fourths. So you would cut that into 4, and this into 4. And you would want negative 7 of them. So you would start counting 1, 2, 3, 4, 5, 6, 7. Okay? And you still land here. So 1, 1, rad 2. Cosecant is going to be rad 2 over 1. So rad 2. We will practice these a lot before Monday's quiz. Just make sure you look over that 4-2 review for tomorrow. And you ready for that?
Nick, did you understand a lick of that? I got half of it.
Measure everything like that.
Yeah, but how much should a lick be? Yeah, a lick can be whatever you want it to be.
Yeah.
Oh, I'm still a faucet. When you're tired, it's easier to keep the entertainment. Well, I'm not alone.
So like, I was in the house. I woke up now. Did you ever get my son goes? No.
You know, I'm having a series of
No, that's great.
I had a really.
I started for your right now.
I said, right?
They were
Seriously.
Yeah.
My dreams are horrible.
You can still say.
My dream
It changed
was.
it. Uh-huh.
It's the season.
Yes.
Fine, well, I'm out.
I was just.